We are picking up in lesson 2.6 where we left off yesterday. We talked about quadratic formula yesterday. About x equals negative b plus or minus the square root b squared minus 4ac all over 2a. We basically spent our day doing some examples, didn't we? We looked at how to simplify square roots that need simplified, imaginaries, we had rational, irrational, and we talked about what types of solutions these were. And I kept saying that leads into today, doesn't it? And that's what we're going to look at. So, and I can put this back up later at the end of class for people that need to get it filled in. But I'm going to the back side now. And we're going to talk about the discriminant. Okay? The discriminant is this part right here, b squared minus 4ac. Does that sound familiar? B squared minus 4ac is the part of the formula under the radical, right? And just by doing the calculation of the discriminant, the b squared minus 4ac, we can learn a lot about how many answers there are and what type of answers there are. So, for an example here, in an equation like this, x squared plus x minus 2, okay, equation given that goes with this graph, you would get b squared minus 4ac to be greater than 0. Now, what do I mean when I say greater than 0? Mathematically, I'm saying that if something is greater than 0, it is positive. So if your discriminant is positive, what it tells me is there's going to be two solutions that are real. So two real solutions. Because what it tells me is there are two places where my graph crosses the x-axis. And those are my two solutions. Now, they could be rational, they could be irrational. And we'll talk about that as we go through these. We talked yesterday about rational versus irrational. I need to make sure with this class that I really clarify. I think I kind of maybe skimmed over the difference between rational and irrational. So I probably need to make sure I really hit that piece of information today. So, if your discriminant is positive, there's two real solutions. Middle example. If your discriminant, b squared minus 4ac, equals 0. We had one like that yesterday, where the discriminant equals 0. How many solutions are there? There's one. That was example D. It was example D yesterday, where we got one solution because our discriminant was 0 here. Okay, so we got one repeated solution. And then the other option. A number can be positive, it can be 0, or it can be, what's less than 0 going to mean? Negative. Okay, and I guess before I forget, realize the one real solution here is the one place my graph touches the x-axis, right? So it's when your vertex is on the x-axis. Over here, when your discriminant is negative, well, keep in mind, my discriminant is under a square root. What happens when you take the square root of a negative number? We get imaginary solutions, right? Or non-real solutions. So when you get a negative discriminant, there's still two solutions, but they are not real solutions. They are imaginary solutions. And this is the case because where does my parabola touch my x-axis here?
Nowhere.
And it doesn't. So when your parabola is either all above your x-axis or all below your x-axis is when you're going to have imaginary solutions. We had that happen on example B yesterday. Okay? Now, we're going to use the discriminant to figure out how many solutions, what types of solutions, without working through the whole quadratic formula. So, example A. Find the discriminant of the following equations. Then use it to determine the number and types of solutions. So, is there 0, 1, or 2 solutions? And are they real, not real, complex, rational, irrational, repeated, all those different things I mentioned yesterday. So, let's start off with the discriminant here. B squared minus 4ac. Now, in order to find the discriminant, you may or may not write them down, but we need to discuss what our ABCs are. What are my ABCs? A is 16. It's in front of x squared. B is 8. It's in front of x. And C is 1. And just like yesterday, before we get our ABCs, our equation is going to have to equal 0. Okay, it's going to have to equal 0. So, do the math here. B squared, so 8 squared, minus 4 times A is 16 times C is 1. By the way, you might want those calculators again today, huh? I know 8 squared is 64. 4 times 16 is?
Equals 0.
64. And 64 minus 64 is 0. Okay, guys. Look back up at the chart up above. When my discriminant equals 0, what's it say about solutions?
2. Oh, wait.
And my discriminant equals
1 real solution.
0. There is one real solution. Now, in Savas, it's not going to just say one real solution. It's going to say one real, remember what we did yesterday? Repeated solution. Because technically what it is there's two identical factors. Okay?
Colby Buzz, 6% high velocity. Colby Buzz, 6% high velocity.
So one real repeated solution. Okay? Is what you would see in Savas. And that's because my discriminant was 0. There's going to be one real solution, and it's going to be a repeated solution. Okay, B. 2x squared equals 5x minus 6. Thoughts on where to begin? What are my ABCs? You guys just all jump into this?
2. Oh. 2.
Okay, if A is 2, what's B?
Negative 5. Negative 5.
Well, it has to be true before we can talk ABCs.
Oh, yeah.
The equation has to equal 0. So you can go either way with this. We can move the 5x and the 6 to the left, or you can move the 2x squared to the right. It honestly doesn't matter. Okay? I don't have a preference either way. If we move the 5x and the 6, we're subtracting 5x, adding 6. So it's 2x squared minus 5x plus 6 equals 0. If you did the other way, you could have ABCs being all the exact opposite signs, and that would work as well. Okay? So now, based on this, A is 2, B is negative 5, and C is positive 6. So, now do your discriminant. B squared minus 4AC. B is negative 5. So negative 5 squared minus 4 times A is 2 times C is 6. Okay. What do we know about negative 5 squared?
It's positive.
It's positive 25 minus 4 times 2 times 6. 4 times 2 is 8. 8 times 6 is 48. 25 minus 48.
Negative 23.
Okay, and here's my deal. My brain says negative. I at least know that, yes? Now, I do think in homework sometimes they ask, what is the value of the discriminant? So what is the value of the discriminant? Negative 23. And what do we know about negative 23?
It's negative.
It is negative. So, how many solutions? What type of solutions am I going to have?
2 non-real solutions.
Okay. Because if I go take the square root of negative 23, I'm going to get an I, right? I'm going to get imaginaries. So we're going to have 2 imaginary solutions or non-real solutions. So I'm going to say 2 non-real solutions. Because they're non-real, you guys remember me throwing the word complex in yesterday? They're complex. Okay, 2 non-real solutions. They are complex solutions because what's a complex number? A complex number means that it's in the form a plus bi, right? And a plus bi means it is imaginary. Okay? So the wording I think you're going to see in the homework is 2 non-real complex solutions. So this part moves a little quicker than yesterday, doesn't it? You've got some quadratic formula in homework. Do the quadratic formula. You've got some find the discriminant and answer questions about the discriminant. Okay? Okay, are you guys on to C without me?
Yeah. I'm going to move on.
So what do we know about C?
Yeah,
We've got to make it equal to 0 before we think about ABCs, don't we? So in order to make this one equal to 0, I would say add 11. So x squared plus 7x plus 11 equals 0. I'm going to list my ABCs. You don't have to. I just wrote that A is 1, B is 7, and C is 11, correct? Okay. Discriminant, B squared minus 4AC. So 7 squared minus 4 times 1 times 11. 7 squared is 49. 4 times 1 times 11. 44. What is 49 minus 44? It is 5. What do we know about the number 5? It's positive.
Positive.
Okay. Because my discriminant is positive, how many solutions am I going to have?
2.
2. What type of solutions?
3.
Real solutions, yes? Now, I'm going to go ahead and write 2 real solutions, but then here's the deal. The homework's going to ask, are those 2 real solutions rational or irrational? So think about that. We're going to have 2 real solutions. Okay? In order to determine rational or irrational, look at your discriminant. If I took the square root of 5, Is the square root of 5 rational or irrational? Is the square root of 5 going to be a number that I can then turn into a fraction? Or is it going to be a big, long, messy decimal like pi? And here's the deal. If you don't know that square root, it's a big, long, messy decimal, isn't it? Okay? So, because I don't know what square root of 5 is, it is irrational. Or let me rephrase, I shouldn't say because I don't know what it is, because it's not a perfect square. Technically, there could be a perfect square, you just don't realize it. Okay? So this is going to be two real irrational solutions. And I don't know if I wrote it for you guys yesterday or not, but irrational numbers are the big, long, messy decimals, or decimals that do not end or repeat. So if you're someone that would prefer to have a definition written down, decimals that do not end or repeat, or I should say decimals that do not terminate and do not repeat. Okay, those are your irrational values. And you have to know that to do homework today. D. 6x squared minus 15 minus x. What's the value of the discriminant? In order to find the value of the discriminant, did you make your equation equal to 0? When I rewrite this, what's the catch? Where's that x need to go?
In the middle.
In the middle. So 6x squared plus x minus 15 equals 0 is going to give you your best chance of getting your correct ABCs. A is 6, B is 1, C is negative 15. I don't think that's the part you need my help on, is it? I hope we can figure out our ABCs at this point. Okay. What is the value of the discriminant? So what is b squared minus 4ac? 1 squared minus 4 times 6 times negative 15. 1 squared is 1. Well, I personally see a minus 4 times a minus 15, which means my brain says I know it's going to be positive. I know 4 15s is 60, and 60 times 6 is 360. What is 1 plus 360? 361. What do we know about 361? Again, it is positive. What do we know about a positive discriminant? There's how many solutions?
2.
2 of the real or non-real variety.
Real.
Real. So because it's positive, I know that there are 2 real solutions. And this is just coming from the chart up top, right? Now, when you have 2 real solutions, they're sometimes going to ask you, are those rational or irrational solutions? So how do I decide that?
Square root.
Check and see, do we know the square root of 361? Well, I'll be honest, I don't know the square root of 361, but what's your calculator say about the square root of 361? Oh, square root of 361
19.
is 19. That changes things up, doesn't it? Can 19 be made a fraction? Yeah, it's 19 over 1. Any number that can be expressed as a fraction is rational. So this is going to be two real solutions that are rational. And it's rational because it can be expressed as a fraction. Okay? So hopefully I've tried to give you good examples of all the different possibilities you'll see in homework. Don't guarantee I've succeeded there, but you know, tried to help with all the definitions, the wording, the vocabulary. That was a big goal of mine here. Yesterday we ended notes by talking about Dion. Guess what? We're going to end notes talking about Dion again.
Dion.
Okay? Dion throws a ball into the air. The height h of the ball in meters at time t seconds is modeled by the function h of t. That information is identical to yesterday, I believe. Different question. When will the ball reach a height of 5 meters? No, I read that wrong. Not when will it. Will the ball reach a height of 5 meters? That's a big difference. Now, what do we know about that 5? It's h, yes? Right there, h is 5. So what can I do to this equation? You can put h in for 5. So if I set my equation equal to h, negative 5t squared plus t plus 4 equals 5. Well, it has to be true before I state my ABCs. Has to be equal to 0. How do I make this equal to 0? Subtract 5. So now my equation becomes negative 5t squared plus t. And then 4 minus 5 is minus 1 equals 0. Do I have to do my whole quadratic formula out here? Does this ask when the ball will reach a height of 5 meters?
It will.
Will it? So this is a yes or no question. Okay. 50-50 shot if you guess right now and stop here. However, I prefer we know how to do this. I spent today talking about the discriminant. Could the discriminant help me? Will the ball reach a height of 5 meters?
Yes.
How about, will there be real solutions to this problem? Would that answer the question?
Yes.
Yeah. So we only have to do the discriminant here. Your b squared minus 4ac. So, a is negative 5, b is 1, and c is negative 1. So 1 squared minus 4 times a is negative 5 times c is negative 1. 1 minus 4 times minus 5 is 20 times minus 1 is minus 20. What do you know about 1 minus 20? It's negative 19. What's a negative discriminant say? There's two non-real solutions. So are there any real solutions?
No.
No. So if there's no real solutions, will this ball ever reach a height of 5?
No.
No. I mean, if we're going to talk about imaginary time, sure, you know, but we're not going to reach a height of 5 meters. And I really set this up kind of awkward, so I'm going to put my information over here. Because it was negative, that means there are no real solutions. If there are no real solutions, then will the ball reach a height of 5 meters? No. Ball will not reach 5 meters. Okay? So that's the idea there of how we can use a discriminant. If we needed to find when the ball reached 5 meters, we would have had to actually use the quadratic formula. Although that would have been extra work because you wouldn't even get an answer there. Okay, you guys have some work time to be working on lesson 2.6 in Savas. Savas should be updated and saying that it's due tomorrow. If it still says today, let me know and I have to try and adjust that again. But I believe it says it's due tomorrow.